Alright, so today we're going to be talking about how to write equations of lines in point-slope form and how to then use point-slope form to rewrite it back into slope-intercept or into standard forms. So point-slope form is in this form. Y minus y1 equals m times x minus x1. So what you're going to do is you're going to plug in your slope into the m value. And you're going to plug your x-coordinate point into x, your y-coordinate point into the y1 right here. And once you have that equation, you're going to rearrange it into either slope-intercept or standard form. Today I'll be telling you which ones I want you to rewrite it in. In the future you pick based off the kind of discussions we'll have when it will make sense to write in slope-intercept, when it makes sense to write in standard form. Okay? So for the first 5 examples, we're going to talk about how to write it into slope-intercept. So we're given our slope is 3, our point is negative 4, 3. So you're going to plug everything back into y minus y1 equals m times x minus x1. So it's y minus 3 equals 3 times x minus a negative 4. So minus negative becomes plus, so that becomes plus 4. So when I distribute my 3 to the whole expression, we get y minus 3 equals 3x plus 12. So I add 3 to both sides, so y equals 3x plus 15 is the equation in slope-intercept form. So again, this is the process you plug into point-slope form, and then you write into slope-intercept. We did this last time by plugging into y equals mx plus b, finding b and rewriting it. Sometimes I would suggest this is a little easier process to work through. So our slope is negative 5, point is 7, negative 2. So it's y minus a negative 2 equals m times x minus 7. So again, minus negative becomes plus, so this is y plus 2. When I distribute my negative 5 into the expression, we get negative 5x plus 35. And when I subtract 2 from both sides, we get y equals negative 5x plus 33. There's my equation in slope-intercept form. Same process for here. Now our slope is a fraction, but that's okay as we're about to find. So we plug in, it's y minus 5 equals a negative 2/3 of x minus a negative 6. Again, minus negative becomes plus, so it's y minus 5. And when I distribute my negative 2/3 into the problem, we have negative 2/3 x, and the negative 2/3 times a positive 6. Negative 2 times 6 is negative 12. Divided by 3 is a negative 4, so it's minus 4. Then we add 5 to both sides. Y equals negative 2/3 of x. When I add 5 to negative 4, we get positive 1. So as you can see, even though you're going to have fractions here, generally whenever you want to convert into slope-intercept form, make sure your fraction goes into that x value here nicely. If it doesn't, that's where we're going to do standard form, and we're going to see that in a couple examples from now. So I want you to try this one on your own. You're going to plug these points into your point-slope form, and then convert that to slope-intercept by distributing the slope, and then adding or subtracting the y value from both sides. Alright, so the equation you should be getting, y equals 3/5 of x minus 11. That's your equation in slope-intercept form. So again, I want you to do this one on your own as well. Put in point-slope form, convert to slope-intercept. Alright, so you should be getting y equals 7/4 of x minus 13 for your equation. So most times you're going to be rewriting these equations into slope-intercept form after you plug into point-slope. There will be some times though you're going to rewrite it into standard form, so let's practice that. So we want to convert this from point-slope form into standard form, so we're going to plug into that part first. So when I plug it in, we have y minus 5 equals 2 times x minus a negative 1. First thing we want to do is we still want to distribute the slope into there first. So it's y minus 5 equals 2x plus 2. Now, standard form is in the form ax plus by equals c. So we need to move our x over to the other side of the equation, and move this 5 over to the other side. So I have to subtract 2x, so it's a negative 2x plus y, and I have to add 5, equals 7. So that's my equation in standard form. So the process is still the same. You still want to distribute the 2, but now after we do that, we need to move the x over, and then move the constant over the 5. So I'll do that for this one right here. Plug it into point slope form, distribute your -3, and then move things around. Right, you should be getting this equation for your standard form. 3x plus y equals 27. Now, normally, if you were to ever do these problems on your own without directions, I would probably never write into standard form if my slope is a nice whole number. Would never do that. I also would never write in standard form if my fraction went into the x variable nicely. However, problems like this is when you're going to want it right in standard form. So I plug in, I have y minus a -4 equals 2/5 of x minus 6. So this becomes plus, so we have y plus 4 equals 2/5 of x minus 6. Now, we don't want to distribute our 2/5 into the problem, because 2/5 into 6 does not go nicely. We could do 2 times 6 is 12, divided by 5, and fraction, decimal. Not really something I want to really work with. So if I want to write in standard form, in this particular case, because that's the directions, or in general, I would probably want to write in standard form if this was just any old problem, what we need to do is, again, standard form is ax plus by equals c. There are no fractions, so I need to get rid of my fraction by multiplying everything by that denominator, 5. So I get 5y plus 20 equals 2, and then my x minus 6. Now there are no more fractions. Now distributing the 2 in nicely works out pretty well. 5y plus 20 equals 2x minus 12. I move my 2x over by subtracting. Move my 20 over by subtracting. And I get negative 2x plus 5y equals a negative 32. And I'm done. There's my equation in standard form. There are no fractions. The problem is relatively easy to deal with, so I didn't have to deal with fraction decimals by distributing, and life's good. So again, for the directions for this stuff, they tell you to convert into standard. That's what you must do for fractions. Multiply everything by the denominator to clear it out, and then work from there. On your own, it's your choice. If you would rather distribute and then just deal with your fractions and decimals, have it in slope-intercept form, fine. Don't care. If you'd rather rewrite in standard form by doing that, go for it. But again, directions say convert to standard, you have to convert to standard. Let's do this one together. So we would plug in, so it would be y minus a -1 equals negative 3/7 of x minus a -2. So we have y plus 1 equals negative 3/7 of x plus 2. Since I have a fraction, I multiply everything by that fraction, the 7. So I get 7y plus 7 oh boy, okay, pause for a second. Alright, sorry about the pen was not working, so hopefully it can go back to being working now. So 7, there we go, plus 7 equals negative 3 times our x plus 2. So now we go ahead and distribute. So we have 7y plus 7 equals negative 3x minus 6. I move the 3x over by adding, so it's 3x plus 7y. Move the 7 over by subtracting, equals negative 13. And there we have our answer in standard form. That's all you need to do when you have fractions for standard form. You need to multiply everything by that denominator to clear it out, then distribute like usual, move around like usual. So you're going to do this one on your own, clear out your fraction, rewrite it into standard form. Alright, so your equation in standard form should be negative 5x plus 8y equals 4. So make sure you're getting that for your final answer. Okay, so that's all you need to worry about for the point slope form plugging into your equation. So yeah, writing equations of lines, you can plug in a point slope form and work with it as we discussed today. Or you can do as we discussed last time, where you plug into slope-intercept form, solve for the b, and rewrite your equation like that. Both are perfectly acceptable. I don't care which one you go with. You just need to pick which one you like best. Alright, so I'll see you next time we talk about parallel and perpendicular lines.